Good morning and good afternoon. Hopefully everyone has had a great day today. Today I'm going to be going over a couple of STAAR questions from our STAAR question preparation review that we are doing in our math class for our Algebra 1 end of course. So I am not going to cover every single question. I am going to cover a couple of questions, not all of them, just a couple of them that are going to hopefully better your process to try to get you to pass or try to even get you at the meet or the master's level on the STAAR assessment. So once again, one of my recommendations is to look at each problem, try it out before you see the explanation, pause the video, and then try it out. If you get the right answer, then you know you're headed on the right track. If you don't get the right answer, then just go ahead and pay attention to how we work it and how we work every single problem. So let's go ahead and get started. So we're going to go ahead and look at question number 1. Which expression is equivalent to 2m to the 4th, 5m to the 8th? So first of all, we're going to multiply here. We're going to look at the 2 and we're going to look at the 5. And we are looking at that one right there, 2 times 5. And of course, 2 times 5 is 10. Automatically we know we can eliminate C and we can eliminate A, so we have the answer choice of B and D. So we're gonna multiply with the same base, so we're gonna keep the same base and we're gonna add the exponents. So what is 4 plus 8? 4 plus 8 is 12. So the answer choice is B. Whenever you multiply exponents, you are going to add the exponent. Okay, let's go ahead and look at question number 3. The graph of the quadratic function is shown. What are the x-intercepts of the function? We got to understand the x-intercepts are also called zeros. And this is where exactly the graph does cross the x-axis. So we're going to look at that and we're going to see this one right here is an x-intercept. This one right here is an x-intercept. So let's label our zeros. This is x is 3, comma 0. And this is negative 1, comma 0. Remember that our order pairs are x, comma y. So our x is negative 1, comma 0, 3, comma 0, 1. So those are our two zeros. In addition to that, we can also label, we can also call these as being negative 1 and 3. There's a couple of other criteria to this quadratic. We got to understand that this right here is a maximum vertex. If we look at the maximum vertex, we are going to look at the vertex label of being x as 1 and y as 3. So our vertex is 1, comma 3. If we want to know our axis of symmetry, this is a line that crosses and cuts your U shape in half. So our axis of symmetry is always x equals to the x value of the vertex, which is 1. So our axis of symmetry, the way we remember in class, is we always look at the axis and we circle the x, and x equals to the x value of the vertex, and the x value of the vertex is of course 1. And the last thing we have to know about this quadratic is what is a y-intercept. In black you will see the y-intercept, and of course whatever the y-intercept is, it's 0, comma I believe 3. So those are criterias for this quadratic. If we're looking at the next one, we are looking at number 5. This is a very easy one with Desmos. So we have our f of x. Remember that we don't want to pay attention to f of x because it's just a fancy word of saying y. So all we have to do is input that equation into Desmos and let Desmos do the work for us. So I'm going to go ahead and input 3 open parentheses, 2 divided by 3, close parentheses. I got to either press here or I can do this arrow, close my parentheses, raise to the x. And how do I raise it to the x? All I have to do is a raised to the b, and that goes to the x. Automatically, we find our y-intercept, right there. If you can see on the table, it is 0, 3. That is our y-intercept. Now, in order for us to figure out that that is a y-intercept, we're going to go ahead and make sure we click on it. If it doesn't stay, then that means that's not our y-intercept. Remember, our graph will give us our, well, it kind of, we can already get rid of letter B, and we can get rid of D. Because remember that the U shape is going the other direction. Now we have to look very closely, even though we see letter A kind of looks similar to this one. But we gotta not let looks, we gotta see right here, that is our x-intercept. Our x-intercept is at 1. And if you look at this graph, which I'm gonna put in blue, or not our x-intercept, sorry, our y-intercept. Our y-intercept is 3. And our y-intercept is 1. Do you remember our y-intercept, as per Desmos, is 0, 3. So we know this one is wrong. Remember, this crosses the y-intercept at 0, 3. And our y-intercept, so the answer choice is C. If we look at number 6, we're going to talk about this quadratic function. F of x means we're looking at the zeros. So we have two zeros here. We have an x being 7/5, and we have an x being 2/3. So what I'm going to do is I'm going to input it into Desmos and find out what my zeros are in decimal form. Remember that Desmos likes decimals. Just like Desmos, Desmos likes decimals. Desmos likes decimals. So again, 7/5, Desmos likes decimals, is 1.4. So this is one of my zeros. And my next zero, and we're going to let Desmos do the work. We're going to put -2 divided by 3. And it's going to give us about -0.666666 all the way to 7. So again, we're looking at our zeros being that. So we're going to first put this function, and remember the f of x. Let's not put the f of x. We're going to look for the zeros being one of these two. So I'm going to go ahead and input the first one and find out if the zeros are. So this is f of x is equal to 14x squared plus 11x minus 15. So all I'm going to do is input it. So I'm going to do 14x squared plus 11x minus 15. And then I'm going to get this one, and I'm going to find my zeros. My zeros are 0.71, and my other zero is -1.5. Remember, I'm looking for zeros to be 1.4 and -0.6. So automatically, A is wrong. Let's go ahead and look at B. And remember, we're looking for zeros to be 1.4 and -0.667. So I'm going to go ahead and input the second one. And of course, if I want to leave it there, I can leave it there. So I'm going to go 15x squared. And you can continue inputting them and checking and pausing the video, seeing if you're headed on the right track on the problems that we are doing together. Remember, I will not be doing all of them. I will only be doing some. So my zero here is 1.43. And my other zero here, and I forgot to put 14. Sorry, I inputted it wrong. That's why it's very careful to input it correctly. 15x squared minus 11x minus 14. Now I'm got the correct zero, so there you go. 1.4 is 1, and my second zero is -0.66667. So this is my correct answer, letter B. And in order for me to check that that is a correct answer, I can also input this one. I can input this one, but again, that is not going to be a correct zero. And this is the correct answer choice. I would recommend to still go in and try it out. So that is number 6. The next one I'm going to do is going to be number 7. So we're going to look at number 7, and we're going to look at the initial price of the item before the store manager made any adjustments. Was this price, the price of the item increases or decreases at a rate of 1 90, or 110. And the reason that they give you that is because we're either going to subtract 1, we're going to add 1, depending on our increase or decrease of rate of change. So first step, we got to find out what x is at 0. That is your initial price. So the way I can get two answers on this one is I look at this equation right here, 320, and I'm going to put x as a number of weeks, so I want to find out what the value is at 0 weeks. And why am I going to find out 0? Because this is my initial price at 0 weeks. Then I'm going to put in another one. I'm going to put in 320 times 0.90, and I'm going to put a 1. This, with these two values, I can get the first one and I can get the second one already right. So if I look at that, I'm going to input 320, open parentheses, 0.90, close parentheses, raised to the AB, and then I'm going to put a 0, and I'm going to say, well, my initial price is 320. So this right here is my initial price. Remember that this is our initial, this is our y-intercept. Just looking at this, the way the form is going. Now I'm going to, in place of putting 0, I'm going to put what is my price after the first week. So instead of the 0, I'm going to scroll back and I'm going to put 1. What happens after the first week? It goes down to 288. So I can already see it is a price decrease. If I want to keep on testing the next one out, all I have to do is click here, go to after 2 weeks, 259. After 3 weeks is 233. After 4 weeks is 209. After 5 weeks is 188. So already knowing our initial price, what is the initial price? Our initial price at 0 weeks is going to be 320. I already can find out my first answer, and it is letter B. The price of the item is going to either increase or decrease. I'm going to look at my 0 weeks, 1 weeks. It's going to decrease. It's going to continue to decrease after 2 weeks, after 3 weeks, after 4 weeks. So the price of the item decreases. So I'm going to circle B. And of course, at a rate of 10%, 90%, or 110%. So there is a key to this. What I'm going to do is I'm going to get my 90, since it's a percent decrease, and I'm going to subtract 10 from it, which is subtracting a 1. So I'm going to subtract 10 to get me the percentage. So all I have to do is do 10, which is a decimal, 0.00, and I subtract 90, which is my 90. This gives me 10%. It's going to be a 10% decrease. So once again, if you want to test it out, all you have to do is multiply by that, and it should give me the answer, 10%. So that one, hopefully you understood that. I know this is a complicated with exponential, but if you understand it, you should be well on your way on how to figure it out. You can always figure out the first two by just inputting the first one at baseline 0 and the second one at baseline 1. You can input another one at baseline 2 weeks and see whether it's an increase or a decrease. Okay, if we look at number 8, which expression is equivalent to square root of 75, and we're given A, B, C, and D. So this is one of our simple ones that I would recommend that for you to do to make sure that you conduct it on Desmos. So the first step, I'm going to do square root of 75, and I'm going to input square root of 75. And that gives me 8.66025. So if it is equal, I'm looking for one that is equal. One that is equivalent is the same as saying equal. Equal is the same as saying equivalent. Equivalent is the same as saying equal. So we're going to input letter A, 5 square roots of 3. So all I have to do is put into Desmos and let Desmos do the work for us. Square root of 3. And it is 8.66025. So automatically, I already know that my answer choice is A. If I want to try B, all I have to do is erase this and input 15 square roots of 5. And I know 33 is not equal to 8.66, so again, B is wrong, and I can do a test on every single one of them. My answer is A, because it is equal. So we're going to look at number 9 now. So go ahead and try this one on your own. Remember, the rate of change is the same as writing slope. Slope is the same as writing rate of change. So which value? We're looking at a negative slope, because anytime a line goes down like this, it's going to be a negative slope. You're going down the mountain, so we're having a negative slope. So automatically, I can already get rid of B, and I can get rid of C. So now my answer choices are either A or C. So now what am I going to do? I'm going to find the x-intercept. I'm going to find the y-intercept. And my x-intercept, if I look at my x-intercept, it is 10, comma 0. If I look at this right here, this is my x-intercept. If I look at my y-intercept right here, it is 0, comma 60. So I have my x-intercept, I have my y-intercept. Those are the more consistent terms that I have here, or this consistent order pairs. So what am I going to do to find slope? I'm going to go ahead and input this into Desmos in a table format. So I'm going to go ahead and input this one into Desmos and find my rate of change. So I'm going to go ahead and input 0, comma 60, which is my x and y. Then I'm going to input the second one as 10, comma 0, which is my x and y. Then I'm going to add regression, or press this little leaf with this little dots. And here it is. My slope is y equals mx plus b. My slope, or my rate of change, is -6. So the answer is letter A. And once again, if you look at the regression, it's in a linear regression. It gives me y equals to -6x plus 60. And once again, this right here is my slope, and it's in the format of y equals to mx plus b. So the answer is A. So that is how you figure that one out with the slope. So the next one I'm going to do is number 11, because of course we're going to look at the ones that we can get right. I know the other ones just take time, but we're going to try to get on the problems that we're going to get right. So what are the factors of 2x squared plus x minus 15? Select two correct answers. So this is one that will always be given on the STAAR, sometimes one, sometimes two of them, sometimes three questions. The factors. This just means that factors are if it passes through the x-intercept. It's got to pass through the exact x-intercept. So what am I going to do here? All I'm going to do is input this into Desmos, 2x squared plus x minus 15. Do I have to put a y? Do I have to put 0? No. All I have to do is put this quadratic into the equation, and that will give me my answer. Okay, there it is. It's a U shape. If you look at that, it's a minimum because it's got the vertex at the bottom. But we're not interested in any vertexes. We're not interested in any y-intercepts. What we're interested in are in these two x-intercepts. So what we're going to do is we're going to graph every single one of these right here. And whichever one passes straight down the x-intercept. So this is my U shape. These are my x-intercepts on these dots. So whichever one passes straight through my x-intercept, that is a factor. So I'm going to just plug in each one of these, and we're going to see if it does pass. So the first one is x plus 3. And remember that you might have a different letter. If you have a different letter like m squared, it's the same thing. Just replace it with an x. No biggie. There you go. The black one passes straight through, so that is one of our answers. So it is correct. I'm going to go ahead and input every single one of them. So I'm already done with this one. And I'm going to go ahead and input the next one. So it's going to be 2x. And again, try them out. See if you can get it by yourself without me showing you the work. This one doesn't pass through my x-intercept. It doesn't pass through this one. If I look at it, it doesn't pass on the purple. It doesn't pass through here. And it doesn't pass through here. It almost passes, but again, we want it to pass through the x-intercept. So this one is not an answer. We're going to go ahead and put in the next one, x plus 5. I'm going to go ahead and input x plus 5. And that one does not pass through neither one of the x-intercepts. It doesn't pass through that one or that one, so these are both wrong. Let me go ahead and put in 2x minus 5. And there's another one. That one passes straight through the x-intercept. Most likely that is our second answer. This one was wrong. So let's test the other ones because again we want to get 100% on this easy problem. X minus 3. I just go put x minus 3. I take out this one because I don't want to get confused. The green one. And I go x minus 3. Nope. Doesn't pass through my x-intercept. And sometimes they look very, very close. So you got to sometimes zoom them in. Does it pass straight through my x-intercept? It does not. And it does not. So this one is not an answer. And then I'm going to try my last one. And I can input them. And I'm going to put 2x plus 5. 2x plus 5. And that one doesn't pass through my x-intercept. So my answer choice is 2x minus 5 and x plus 3 are my two answers that are factors. And in order for them to be factors, they got to pass straight through the x-intercept because that is a solution. So I want to check it to make sure I got the right one, to make sure I checked off the right one. I checked off 2x minus 5, so I'm going to click on it. Yes, it does. It passes straight through my x-intercept. Right there at 2.5, and I'm going to check my first one because that is another one. It passes straight through my other intercept, which is right here at negative 3, 0. So once again, those are the factors. We're going to look at number 12, and I'm going to let you do this one by yourselves. We're going to look at the part of the quadratic function graphed on the grid. There's a part of it, and of course, we are looking for domain, and the key word for domain is x. So we are looking for domain, which is our x. So as we can see on the graph, our domain starts at negative 1. We can't say negative 2 is part of the graph. We can't say negative 3 is part of the graph. So if you look at this, it starts at negative 1 and it keeps on going. If you look at it, it goes to negative 1, keeps on going. And you see that line, it keeps on going forever. So we know it's going to be negative 1, 0, 1, 2, 3, 4, 5, 6, 100, 1,000, a million, a trillion, a quadrillion. And of course, it keeps on going and going and going. So the domain is part of the function shown. So which one would be correct? If I would say all real numbers, that would be wrong because, again, negative 4 is not part of the domain. Now, all real numbers greater than or equal to 1. What about negative 1? What about 0? That is wrong. All real numbers greater than or equal to negative 1. Remember, this dot means that it's including negative 1, so it's negative 1. And the answer choice is letter A. If we say all real numbers greater than or equal to negative 1 but less than 5, what about 6? What about 7? What about 8? What about 9? What about 10? What about 11? So that one is wrong. So the answer is A. If you look at the next one, number 13, that's another one that we are going to work. The graph of the linear function is shown on the coordinate grid. So once again, we got to look at the graph closely. We're going to look at two key factors, which is the x-intercept and the y-intercept. If we look at our x-intercept, it is going to be negative 4, 0. And our y-intercept is 0, positive 2. So our y-intercept is 0, 2, and our x-intercept is negative 4, 0. So what we're going to do is we're going to look at these functions, and we're going to graph them, and we're going to see which one does pass through the x-intercepts and y-intercepts that are given right here that we went over. So let me go ahead and erase this. Remember that I want them to pass through here and through here. This is your x-intercepts and y-intercepts. So what I'm going to do is I'm going to go ahead and input each one. Do I have to put y? No, I don't. I don't have to put y, but if you want to put y, you can go ahead. Right here, I do have my y equals to negative 2x minus 4. Remember, if I know my y equals, and I'm going to go ahead and write it in, y equals to mx plus b. I already know that the b is my y-intercept. My y-intercept is 2. And if I look at my y-intercept, this one is not 2, that is wrong, and this one is not right because it is negative 4. Those are actually my x-intercepts, those are not my y-intercept. So now I have the answer choice B and D. So what I'm going to do is I'm going to graph each one, and I can graph all 4 of them if I want to. And I can put my y, but I don't have to put my y, so I'm just going to put 2x, positive 2. And all I'm going to do is match up the graph. Does it have a y-intercept of 0, 2? Yes. So now I have to look at the other point. Does it have an x-intercept at negative 1, 0? Nope. It's got an x-intercept at negative 4, 0. This is wrong. So most likely the answer choice is D. But I want to make sure I guarantee that I get a correct one. So I'm going to input 1/2 x. And is it okay to put y? Yes, I can put y equals, because Desmos likes y equals mx plus b. 1 divided by 2, and then I do my space, and then I put my x, and then I put positive 2. And then I'm going to check. 0, 2 is my y-intercept. You are correct. And then negative 4, 0, which is this, is my x-intercept, which is correct. So that is our answer, letter D. Okay, so we're going to go on to number 14. Number 14, which statement about f of x is equal to 2x squared minus 36, positive 27? So all I'm going to do is I don't have to worry about this f of x right here. I don't have to worry about it. I'm going to just input this into Desmos, 12x squared minus 36x, positive 27, and then I'm going to look at the characteristics of this graph. So I'm going to put in 12x a to the square minus 36, positive 27. Going to make sure I inputted it correctly. I did not. I forgot my x there. Let's input it correctly. 12x squared minus 36x, positive 27. Now I inputted it correctly. Now I'm going to look at the features of the graph. So I'm going to look at this one, and I'm going to look at the vertex. The vertex of this U-shape, if we look at this, look at that. It's 1.5, 0. That is also my 0, so now I know that it only has one 0 at 1.5, 0. My x-axis of symmetry is the x value of the vertex, which is 1.5. And of course, my vertex is 1.5, 0. So that is going to eliminate 2 answer choices. So I'm going to go ahead and shrink it. If you look at letter A, the zeros are positive 2/3 and negative 2/3. It only has one 0, so this one is wrong. The zeros are 3/2 and positive plus and minus 3/2. That is wrong. So the only 0 is 2/3 and the only 0 is 3/2. So I'm going to look at my vertex. My vertex right here is 1.5. Now all I'm going to do is input this one into Desmos, input this one into Desmos, and find out which one is right. So I'm going to do 2 divided by 3. And my 0 is 0.6667. But again, that's not my 0. My 0 is 1.5. So I'm going to go ahead and input this one. 3 divided by 2. And there it is, 1.5. That is the answer. So my answer choice is letter D. This one is 0.667 and it is not correct. So the answer choice is letter D. We're going to look at this one, number 13. So if you want to try this out on your own, first, and see if you get it. If you get it correctly, then of course you got it correctly. If you didn't get it correctly, then of course you can go ahead and just watch our explanation. So if you can see our linear equation, this is a linear equation. Why? Because it has a line. So it's asking what are the slope and what is the y-intercept. So again, we're going to look at key features of this line. I have my x-intercept at being at 2, and I have my y-intercept at being at 4. So I got to make sure that I look at the line and I write in my ordered pairs. My x-intercept right here is 2, 0, right here. And my y-intercept is 0, -4. And just by knowing those two ordered pairs, I can input those two ordered pairs into Desmos via the table format. So all I'm going to input is here 2, 0. So I'm going to put 2, 0. And then my second order pair is 0, -4. So I want to make sure I have my correct order pair, 0, -4 and 2, 0. I'm going to add regression, and I'm going to get my line. I have my x-intercept, I have my y-intercept. If you look at the equation, it pops out the y equals mx plus b already. And remember that y equals to mx plus b. Remember that the m is your slope and the b is the y-intercept. So I'm going to rewrite it as in 2x minus 4. And that right there will give us our slope. Our slope here, or our rate of change, is going to be 2. So if I look at my slope is right here as 2. It is letter E, so I'm going to shade that one in right here. And my y-intercept is -4, or looking at this graph, my y-intercept is -4. So my y-intercept is A, which is this one. So my y-intercept is -4, and my slope is 2. So again, Desmos does all the work for you. We're going to look at a little bit of FOIL/distributive property on this one. So if we look at in blue, I'm going to underline my z, and I'm going to distribute to every single term. So if you want to try this out without me doing it, you can go ahead and do it. So I'm going to distribute my z into every single term. Try to see if you can get the right answer. So z times z squared is z cubed. Remember, z squared times z is z cubed. Then I go z times -4z is -4z squared. Then I go z and a +6 is +6z. But I'm not done. I finished the first term. Now I got to distribute the 5 into this one, and into that one. So a +5 times z squared is +5z squared. And then a +5 times -4z is -20z. And the last one, +5 and a -6, is a -30. So I'm going to underline the z cubed. Is there any other z cubed? No. So that is the answer, z cubed by itself. I can go ahead and scratch it out. Then I have a -4z squared and a +5z squared. I'm going to do -4 plus 5. -4 plus 5 is a +1z squared. I got my cow with my cow. Now I have my chicken with my chicken. I have 6z and a -20z. I just input that into Desmos. 6 minus 20, which gives me a -14z. I get these chickens out of the way, and my fishes, I have -30 fishes. And of course, a positive and a positive, I can already see that I made a mistake, because of course it is a positive. 5 times +6 is a +30, and this is a +30. And of course right here, 5 times 6 is +30. It's not a -30. Now I have my answer, and I'm going to figure out which one is the correct one. So of course, it's not A. It's not B. It's not D. So it is C. Now look at the mistake I made at the beginning, that I multiplied 5 and times 6 gives me a -30. if I would have found that mistake and I would have gone back and I just would have rechecked the work and I would have come out with the right answer. So that is a little bit about distributive property right then and there. The next one we're dealing with is a graph of a quadratic. So we're going to look at this graph and you're going to tell me which one is correct. So the graph of the quadratic function is shown there. Which statement is best supported? That means that which statement is true. So once again, which statement is true? So we're going to look at this, and this is a maximum. We have a maximum, and of course, we got to find our vertex. Let's see, our vertex is right here at the very top, and our vertex is x negative 3, and our y is about 9. So that is our vertex. Then we have two zeros right here, a negative 6 comma 0 and a 0 comma 0, or about. So it's about 0 comma 0. If I want to find my axis of symmetry, my axis of symmetry is the x value of my vertex, and my x value of my vertex is negative 3. So my axis of symmetry cuts the line in half, and if it was straight, it would cut the u in half, and that is my axis of symmetry. So now I'm going to see which statement is best supported by my answer. The function has a 0 at 6. That is false. Why? Because it has a 0 at negative 6 and 0. It has a minimum value of 9. That is wrong. Why? Because this is a maximum. Why? Because my vertex is at the top of the hill. This is considered a maximum. The vertex of the graph is 9 comma negative 3. No, that's false because my vertex is actually negative 3 comma 9. So again, they mix it up to try to trick you. And the equation of my axis of symmetry is x equals to negative 3. And I know my x value to my vertex is my axis of symmetry, which is x equals negative 3. So the correct answer choice is D. So once again, you have to know the features in order to make sure that you understand this graph. So the next one that I'm going to do is this one. So this is an exponential table. So I'm going to give you some time if you want to work this problem out to see if you get the correct answer. And again, all you do is input it into Desmos, and right here where it says linear regression, all I'm going to do is change it to exponential. Why? Because it says exponential change. Exponential is a small little x. So again, I'm going to get rid of all this, and I'm going to start inputting my table. My x is my years, and my y, f of x is just a fancy word of saying y, is 2735. So all I'm going to do is input the table next. So it's going to be 1 comma 27, 2 comma 35, 3 comma 45, 4 comma 68, 5 comma 93, and 6 comma 124. Then I'm going to add my regression, which is a little leaf here. And then I look at the equation that it gives me, and it gives me 19.485. Something's wrong because, of course, it's x, it's in linear, and the dots are all over the place. So remember that we're not dealing with the linear this time. It tells us right here exponential change. So right here where it says linear regression, we're going to change it to exponential change, which is the exponential regression. And it gives us our y equals to 18.94 times 1.36 raised to the x. So the closest one to that one is, of course, letter C, and that is our correct answer. If you look at that, all they're doing is rounding the 18.94. It's 18.9, and 1.4 is just rounded 1.36, and it rounds up to 1.4. So that's all they're doing. And if you want to input one of the x's for this x, that you can also do that. And in that x, you will get something close to 93. It's not going to be exact because we estimate it. But again, you're going to get something very, very similar. So we're going to go on, and we're going to go on to question number 24 because I want to get a good variety of questions. So first is a sequence. This is a sequence of a to the first equals 5. So that is our first term. So I'm going to rewrite this and say a to the first equals 5. So I can already eliminate a, and I can already eliminate c. Because remember that my first term is 5. So I already have my first term. So it can be b or it can be d. Now the way I think of this term right here, it's always my previous answer. I always see the one before because that's n minus 1. So all I do to get my next one, a to the 2, all I do is say, well, what's negative 3 plus 5? And I do negative 3 plus 5, and I should get my second term. And all I have to do is input it into Desmos, negative 3 plus 5, and that gives me 2. And my second one is right there. So the answer choice is B because it's not an 8. Now if I want to get my third term, all I have to do is say negative 3 plus my previous answer, which is 2. And I'm going to go ahead and put in 2 because this is my previous answer. And that's going to give me my third term. So all I'm going to do is say negative 3 plus 2. And that gives me negative 1. So that is my third term. And then my fourth term, all I would do is negative 3 plus negative 1, which gives me a negative 4, which is my last and final term. You always want to think of this right here. You always want to think of this as the previous term, the previous answer, a to the n minus 1. And let Desmos do the work for us. Next one is a very easy, simple problem. It's a linear equation. And first we're going to discuss what the difference between domain and range is. Domain is your x's, and your range is your y. So if I look at the dots right here, my domain is anywhere from 0 all the way to about this dot to about 9. So my domain in the x is 0 to 9. It's got this closed circle, so it's anywhere from 0 to 9. If I'm looking at range, the range starts at 0 and it goes all the way to about 80. So my range is from 0 to 80. We're asking for range. So remember, the range is my y value. So automatically, by looking at the answer choices, I can get rid of anything that's not a y. This one is not a y. This one's not a y. Now we're going to find out, what is my range? Is it between 0 and 80 and 0 to 9? So all we do is look at the graph. We look at this point right here, starts at 0, and it goes all the way to 80. So all the way up, this is my range. So my correct answer is C, because 0 to 9 would actually be my domain. But again, I would have to have my x in the middle. If I look at the next one is also an easy one, number 26. So I'm going to look at that one. Which expression is a factor of negative 6x squared minus 19x plus 20? So what I'm going to do is I'm going to input it into Desmos. So I'm going to input negative 6x squared minus 19x positive 20. And I'm going to find my zeros. I'm going to find my x-intercepts. if I look at that graph, I can already tell you that this graph is a maximum. Why is my graph a maximum? Because my vertex is at the very, very, very top of the graph. It's way up there on top of the hill. So that's considered a maximum. But I really want to be concerned about my zeros, which is not my vertex. It's -4, 0, and 0.833. And that is my vertex. This is my zeros, -4 and 0.83. So all I do is input A, input B, input C, and whichever one crosses through my x-intercept is a factor. So I'm going to move my graph, I'm going to maneuver it here, and then I'm just going to input every single one. So the first one is 3x squared, 3x minus 5. Is that one a 0? No, it doesn't pass through my 0. So this one is not a correct answer. So A is wrong. So then I'm going to unhighlight this one, and I'm going to go ahead and put my second one. So the next one is 6x minus 5. There it is. The answer is B. But again, I want to make sure that this is a correct answer because sometimes they do look closer than they look, but they are not the right answer. So I want to test out and prove that that is my correct answer. I'm going to input the third one, x minus 5. Nope, not even close. This one is also a wrong answer. And I'm going to input my last one. So I'm going to click on this one. I'm going to get rid of this. And I can move this around if I want to. Then I'm going to input 2x minus 5. And there it is. It doesn't pass through my x-intercept, so the correct answer is B. And if I want to check it, all I have to do is find the 6x minus 5 on the graph over here. It was this one. And it passes straight through my x-intercept, 0.833, comma 0. So that one is a good one. Remember, the keyword is factor. We're looking for a solution, and of course my keyword is x-intercept. Does it pass through my x-intercept? If it does, it's a correct answer. If it isn't, then it's not a correct answer. The next one that I'm going to do on my review is number 28. So what I'm going to do is I'm going to rewrite this equation. I'm not doing anything to it. I'm going to divide it by x to the third and y. So what I'm going to do on this one is I'm going to shrink it a little. I'm going to do equals to, and I'm going to do a big division sign. So what I'm going to do, looking in red or orange, I'm going to say I have a pair of x's right here and I have a pair of y's. I'm going to write an x and I'm going to put a y there. Now I want to subtract -6 minus 3. Remember, when I have the same base, I'm going to subtract the exponents. So I'm going to just input that into Desmos and let Desmos do the work for us. I have -6 minus 3. All I submit is -6 minus 3. And the answer is -9. So this is x raised to the -9 power. Then I have the y, and there's an imaginary 1 on top of the bottom y. And so all I'm going to do is subtract 4 minus 1, and that gives me a 3. And I'm going to put equal, and I like to draw my line so I won't get confused. Now in green, I can never have a negative. So in order to change a negative to a positive, I'm going to multiply by the reciprocal. And instead, we just throw it to the bottom of the numerator. It goes to the bottom and it becomes positive. So the y to the third, we leave it on top. And on this one, I just put it on the bottom. And it's x to the 9th. And that is my answer. So anytime you have a negative in the bottom, you just throw it to the top. If you have the negative on the top, you just throw it in the bottom. Why? Because you're just multiplying by the reciprocal. And the answer choice is letter A. Wrong, wrong, and wrong. So the next one that we are going to be working on is, of course, a function is shown. What is the range? So remember keyword for range. Our range is our y value. So once again, we're going to graph this onto Desmos. So let's go ahead and graph it into Desmos. And we're going to put 2 divided by 5. I'm going to go ahead and do the space. And I'm going to open parentheses, x minus 25. Close parentheses, quantity square. How do I get the quantity square? I raise it a to the square. And then I go positive 13. And my graph doesn't appear, so I need to look for my graph. So all I have to do is click. There it is. It's way up there. So I'm going to look at the range. That's a y value. So I'm going to look at the y value here on the vertex. X value is 25 and my y value is 13. Now we got to understand that the y value is everything bigger than 13. So it can be 14, it can be 15, it can be 16. Any of these points, it can be a y value. It can be a range. But can it be 5? Nope, not part of the graph. 2, not part of the graph. 0, not part of the graph. So automatically I know A is wrong. All real numbers greater than or equal to 25. Well, let's look at the y value because it is range. Our y value is 13. Greater than or equal to 25, that's false. Greater than or equal to 10, that's false. So the answer choice is D. Remember, all numbers greater than or equal to 13, anything above 13, and that's the same thing as all real numbers greater than or equal to 13 because it goes up forever. Okay, let's look at 31 because this is a causation, association, and both or neither. So is this statement a causation, association, or both or neither? So the way we think of it, if they're associated to each other, it's association. It doesn't matter whether it's going up or down, as long as they're related to each other, it's association. For causation, it has to be a cause and effect. So if I slow down my car, that means it's going to take me longer to get there. It's a cause and effect. If I turn on the oven, it's going to take me take me a shorter time to cook it. Or if I turn down the oven, it's going to be longer time, or vice versa, whatever it is. So it happens the same in Florida, happens the same in California, happens the same in Arizona, in Texas, in Harlingen, McAllen. It's got to be the same. So we're going to look at the first scenario. As the outside temperature in degrees Celsius increases, the number of minutes it takes for a bowl of ice cream to melt decreases. So is that association, causation, both, or neither? Automatically, I know the time, the temperature, and the bowl of ice cream, they're all associated with each other, or they're all causing each other. So automatically, neither cannot be a right choice. So I got to determine whether it's both association, or causation. So if I look at the degrees, if I turn down the degrees, if it gets hotter outside, it could melt faster. If it gets colder, it can melt slower. It happens the same whether you're being in Texas, whether you're being in Harlingen, whether you're being in South Padre Island, or whether you're being in McAllen, one part of McAllen or another part of McAllen. So they are associated to each other. It's a cause and effect. They're causing each other. So it is both association and causation. So the answer choice is C. It wouldn't be this one, and it wouldn't be this one. So this is a statement that's both causation and association. As the sales of winter coats increase, the outside temperature decreases. So once again, temperature decreases, so automatically the winter coats increase. That is not true because in Harlingen, the temperature can decrease, and depending on the people, then the winter coats can increase or decrease. So it's not consistent with the temperature. It's not like you're cooking something or you're driving. It's not consistent. So yes, they are associated with each other. Is it a cause and effect? No, because in Florida, if the temperature increases, the winter coats can decrease. In Texas, it could increase with the same variable. So it really doesn't, it's not causation. It's not a cause and effect. It's not both. It's not neither. So this would be an example of only association. So as the sales of winter coats increase, the outside temperature decreases. So this is only they're associated with each other, but that's all that it goes. It's not a cause and effect. Next one that we're going to be working on is number 33. So we're going to look at number 33, the graph of a linear function. So first of all, we don't need Desmos. Why? Because it does everything. Well, we might need Desmos. Let's stand corrected. First, I'm going to look at my graph and I'm going to find my x-intercept. My x-intercept for my 0 is 6, 0. So I have my x-intercept. I want to find my y-intercept. My y-intercept right here is 0, 3. So I can go ahead and input this into Desmos. I have my y-intercept at 0, 3 or 3. My x-intercept is 6, 0 or 6. So I have my x-intercepts and I have my y-intercepts. So I can go ahead and input this into Desmos and let Desmos do the work. I'm going to go ahead and put the table. I'm going to put the first one as 0, 3. And I'm going to go ahead and put my second one as 6, 0. I'm going to add regression, and there it is. My equation right there is, my slope is right there. Y equals to mx plus b. So y equals to negative 0.5 x plus 3. So my rate of change or my slope is negative 0.5. Or I can say negative 1/2. Now, with that information, and if I don't know how to do 0.5, all I have to do is translate it into negative 1/2. They're going to be negative. So I know my slope, it's going down the mountain, so it's also a negative slope just by looking at it. So let's see which one's right. Which statement is best supported by this equation, this function. Remember, vertical line test, it is a function because it only passes through one point, so it is a vertical line test and it is a function. So the slope is 1/2. That is false because I have a negative slope, and automatically if I didn't know what 1/2 was, I knew that was wrong. The x-intercept is 6, so I'm going to come here. My x-intercept is right here, so that is correct. I want to also find the 0, which is the x-intercept of the function, is 1/2. My 0 is not 1/2. My 0 is 6. So this is false. And my y-intercept is 6. And that is false again because we're right here. My y-intercept is 3. So this one is wrong too. So the answer is the x-intercept of the graph is 6. So that is the correct answer. Letter B. Go ahead and try number 34. See if you can get that one. Which expression is a factor of 16m squared minus 81? You want to find the one that goes directly through the x-intercept. But you might say, hey, the m, how do I put m into Desmos? Well, you can't. But the way you write this is all you have to do is write it as 16x squared minus 81. Every single one of these, all I have to do is instead of m, I'm going to change it to x. And I can go ahead and input that into Desmos. So first I'm going to input the first equation, which is a quadratic, which is 16. Instead of m, I'm going to put x squared minus 81. That gives me, and I'm going to find my x-intercepts, and I can always enlarge them here. There's one x-intercept, there's the second x-intercept. Now I'm going to find out if 2x minus 9 goes straight through my x-intercept. If it does, it's a factor. If it doesn't, it's not a factor. 2x minus 9. No, it doesn't. Here's my x-intercept 1. There's my x-intercept 2. This one does not go. I'm going to try my next one. Instead of writing 16m, I'm going to write 16x squared. Positive 19. And there it is. Doesn't go through either one of my x-intercepts. This one is wrong. This one is wrong. So I'm going to go ahead and input my third one. I'm going to get rid of this, and I'm going to put in 8m minus 9, which is the same thing as writing 8x minus 9. And again, it doesn't pass through my x-intercept, so again, this is false. And my last one should be the answer, so this one, I'm going to go ahead and get rid of this. And I'm going to do the last one, 4x positive 9. And there it is. Passes through my x-intercept, and that is my answer. Letter D. Why? Because it passes straight through my x-intercept, and that is my factor. So that is number 34. The next one we're going to do is number 36. So while I take my time to delete Desmos, you can go ahead and try it out. I'm looking for the rate of change given this table. So once again, all you're going to do is input this into Desmos and let Desmos do the work for you. So let me go ahead and get to my table. And remember, my table is right here. And all I'm going to do is input this. Number of minutes is X. And my cost is Y. So all I do is input this into Desmos. 15. Y is $3.05. Now it's just a matter of inputting them. 20. $3.40. 35. $4.45. And 55. $5.85. I press my leaf. I press the regression button. It's linear because it's a rate of change. And here it is, y equals to 0.07. This is what Desmos gives us, 0.07x plus 2. And right here, I already have my rate of change as 0.07. The answer choice is C. And that is my rate of change for that. The next one I want to really focus on is they want me to also find the domain and the range of this linear equation. So all I'm going to do, I'm not going to pay attention to this x. I'm going to find two answer correct choices for this linear line. And I can already tell you the domain of any line, usually a line that doesn't go straight up, straight down. It is all real numbers for x and all real numbers for y. So all I'm going to do is input this 480 into Desmos. It's going to give me a line. So I know the two correct answer choices are the domain is all real numbers and the range is all real numbers. That is the correct answer choices. Anytime you deal with a line, anytime you deal with a quadratic, then you have to be very specific with the quadratic. And then of course, that is a little bit different. If we look at number 38, all we do, and I'm going to go ahead and skip a couple of them. All I'm going to do is I'm going to substitute the x value for these x's, and I'm going to find out which one is true, and that will give you the correct answer. And all I have to do is input it in Desmos. So I'm going to just do the first one and the second one, and one of them should be the answer, hopefully. And I'm going to input the first one, and instead of x, I'm just going to test out 6. And it has to equal to 0, and if it doesn't equal to 0, then it's not a correct answer. So I'm going to say x, which is 6. I'm going to do 6 positive 13, close parentheses, open parentheses, x minus 6, which is 6 minus 6, close parentheses gives me 0. So most likely that is a correct answer. But I want to check it. I want to be sure. Now x is equal to 13. So instead of 6, I'm going to put 13. Just going to replace it right there, and I'm going to replace it right there. Uh-oh, doesn't give me 1, it doesn't give me 0. So here the first one was correct, this one is wrong. So again, this one would not be a correct answer. So now I'm going to check the second one. In place of x, I'm going to just put in place of x, negative 13. So I'm just going to change these to negatives. Change this one to negative. And it gives me 0. So I got the first one correct. But I want to check the second one, so in place of negative 13, all I'm going to do is put 6. I'm going to get rid of this one. And it also gives me 0. So they both give me 0. These are going to be my 2 zeros. So this one is the correct answer. Also, I can also graph this into Desmos, get my 2 x-intercepts, and those would also be my answer. So we're going to move right along to number 41. They're asking for what is the slope that passes through these points. And we used to do y2 minus y1 divided by x2 minus x1, do the math, and then get the slope, but no more. Now all we do is input into Desmos, put into right here. I'm going to put 10, 18. So I'm going to put 10, 18. And then on the x and the y, I'm going to put negative 5, negative 12. Little 2 extra there, only one negative 5, and negative 12. I'm going to add regression. It's a linear, and there it is. Y equals 2x minus 2 under the equation. I'm going to underline the number next to the letter. That is my rate of change or my slope. So the answer is B, just by knowing how to input it on Desmos. If we look at this one is going to be very similar. You're just going to input that one into Desmos on 44. If you want to try it, you can go right ahead. This one is very similar. You input it into Desmos. You make sure the criteria matches, and you find out which one's the right one. Again, this one is an undefined slope. Remember that if it goes straight up, straight down, it's an undefined slope. That eliminates A, that eliminates C. So that is an undefined slope, and all I do is, what does it pass through? It passes through the x. So again, the undefined slope, it is going to be x equals to 6, which is D. So again, I'm only going through the ones that we can do very easily. This is another one we can do real easily. And I want to really spend some time on this one because f of x is the same function. And here my ordered pair. And this looks complicated, but it isn't. All you have to do is understand that this is x. So I'm going to put negative 3 right here, comma 0. This is my ordered pair. 5, negative 4. And they're asking for my function. My function is whatever it is, x, whatever it is. So then that is my y equals to mx plus b. So all I have to do is input these 2 points into Desmos and let Desmos do the work. And again, you can try it out, see if you get the right answer. And if you get the right answer, if you don't get the right answer, then of course you can go ahead and just watch the video. So the first one is negative 3, 0. And the second one is 5, negative 4. I'm going to add regression right here. And here it is. Let me just make sure it's correct. Negative 3, 0 and 5, negative 4. And right here I have my y equals to negative 0.5x minus 15. Or no, 1.5. So right here my rate of change is negative 0.5 next to the x. You have negative 0.5, and this is letter D right here. And then I have negative 1.5, And do I have a negative 1.5? Here it is. And this is letter C. So negative is the same as plus minus. So all I have to do is put it in as plus minus, and it is letter C on that one. So it looks complicated, but it really is super easy. The next one is another easy one. So once again, if you look at that one, which statement is true about the graph? All I have to do is input this one on Desmos, and you can go ahead and try it out. All I do is input this onto Desmos and let Desmos do the work for us. So I'm going to go ahead and input. It's going to be 35 times, open parentheses, 1.4, close parentheses, and I'm going to do a to the b, and then I'm going to do the x, and that gives me my graph. So I'm just going to find my y-intercept. My y-intercept on this graph is right there, 0, 35. There it is, letter A. My x-intercept is 1.4. You can try to find x-intercept, but again, my x-intercept is not 1.4. My graph of the function is decreasing. That is incorrect because my graph of the function is actually increasing. And if you have 1 plus 0.4, then that tells me that it is increasing if it's bigger than 1. So this is false. The asymptote of the function is y equals to 0.4. Actually, the asymptote of this function is going to be 0. Why? Because it approaches 0 but never touches 0. So the asymptote or the boundary is 0. This is false. So the answer choice is letter A. If I look at number 50, 50 is just FOIL. All I have to do is the FOIL method, and I'll do the first one, and I'll just show you how to do one, and then you can do the rest and see if you got the right answer. And the FOIL method is this: k minus 1, close parentheses, k positive 6, close parentheses. So all I'm going to do is the FOIL method, and I'm going to do k times k is k squared. K times 6 is 6k. And then I'm done with this. I'm going to do negative 1 times k is negative 1k. And negative 1 times 6 is negative 6. In the middle, I'm going to combine the ducks with the ducks. So this gives me k squared positive 5k minus 6. And once again, I'm going to look at my answer choice. It's not a positive 5k, it is a negative 5k. So once again, this would not be a correct answer. So I'm going to scratch this one out. And the correct answer, I'm going to go ahead and give it to you. And you can try each one out, see if you get the right answer. The correct answer is actually letter C. And again, you can also input this into Desmos. Instead of putting the k, I can rewrite it as x squared minus 5x minus 6. And find out, input this one in x's and find out which one matches. So if I input x squared minus 5x minus 6. So there's my graph. I'm going to look at my graph right there. And then I'm going to input my answer, x minus 6 right here. I can input the other ones. In order for them to be equivalent, they got to match exactly. Close parentheses, open parentheses, x positive 1. Close parentheses. And if I look at this graph, if I take off the black one, it has to be identical to each other. They got to be equivalent. They got to be equal. So they are equal. That is the correct answer. You can also check it without even doing the FOIL. You can check each one and find out which one overlaps and is identical and equivalent to the graph. So the next one that we're going to work on, what is the simplest form of this expression? So what I'm going to do is I'm going to rewrite this expression in this blank space so you can see it. I'm just going to rewrite it. I'm not going to do anything to it. I'm going to say x to the 6th, y, z to the 7th, all divided by x, y to the 2nd, z to the 2nd. Now in red, you're going to see that I have imaginary 1 there, and I have imaginary 1 there. So I'm going to pair up the x's together. in blue. I'm going to pair up the y's and I'm going to pair up the z's. So now I'm going to do my equal sign. I'm going to do the big division sign. I have a pair of x's, I have a pair of y's, and I have a pair of z's. And I'm going to put equal here. And I'm going to draw a line so I can see it. So again, 6 minus 1 on the x's. 6 minus 1 is 5. So 6 minus 1 is 5. If I look at the y's, 1 minus 2 is negative 1. If you don't believe me, all you have to do is input it into Desmos. And I do 1 minus 2. That gives me a negative 1. And 7 minus 2 is 5. And remember that I can never have a negative exponent. So the positives, they're fine. Leave them alone. X to the 5th, z to the 5th, all over. I'm going to multiply by the reciprocal, which I'm just going to throw it to the bottom. And that's raised to the 1 is your answer. X to the 5th, z to the 5th, and of course y to the 1st. So that is the correct answer for that one. If you don't understand how to do it, rewrite it, go back on the video, try it out, and see if you got the same answer on this one. Okay, a couple more that we're going to be doing. This one we're going to skip. We're going to do this one, rate of change. The table shows the cost of different numbers of square feet of carpet. We have the number of square feet, and then we have the dollar amount. So remember, 1 is the x, this one's a y, the dollar amount, and they're asking for rate of change. Rate of change is the slope. And do remember that y equals mx plus b is what Desmos will pop out. Remember, the number next to the letter is your rate of change or your slope, and this is your y-intercept. So all we're going to do is then put it into the Desmos and let Desmos do the work for us. So I'm going to go ahead and input the table into Desmos. I'm going to put the table 120, 840. I'm going to do 140, 980, 160, 1120, and 180, and 1260. I'm going to check my numbers to make sure I did the correct ones, because this is an easy one. I'm going to add regression. And there it is, y equals to 7x plus 0. So right there, by doing this equation, y equals to 7x plus 0. My rate of change is 7. So my slope or rate of change equals to 7. So that's what they're asking for, rate of change. So that is my answer. If I look at this one's an easy one. The graph represents a quadratic. Try to see if we can do this one. Select one of the answer choices in the box to complete the sentence. First of all, is this a minimum or a maximum? By looking at the graph, where's my vertex? I'm going to find my vertex and I'm going to label it. It's about right there. And my vertex, the x is -2 and the y is 4. So that is my vertex. This is a maximum. So the question is very simple. My vertex is -2, 4. The function has a minimum or a maximum. It has a maximum and value of -6, 3, and 4. All we have to do is look at the vertex. It is -2 and 4. The answer choice to what it is letter C. That's all you have to do. If they would ask for your x-intercepts, all you would have to do is locate 2 and -6. Those are my zeros, or those are my x-intercepts. If they ask for y-intercept, it is 0, 3, right here where my arrow is, x-intercept, x-intercept. And if they ask for axis of symmetry, my axis of symmetry is the x value of the vertex, which is -2. And what does the axis of symmetry do? It cuts the U shape in half. Once again, if it is at the top of the hill, it's a maximum. If it's at the way, way bottom of the hill, it is a minimum. So I'm going to go on to this one, number 8. Go ahead and try that one on yourself, by yourselves. Shade the two correct circles that represent the zeros. And remember, the zeros are also the x-intercepts. So what we're going to do is we're going to identify that the zeros are your x-intercepts. And all we would shade is this one and this one. Why? Because it crosses my x-axis. This one's another one, number 10, that I want to go over. What is the equation and what is the slope? So remember that my equation, anytime that I have a straight line, it is 0. So my slope right here, anytime we have it goes up, rephrase. Anytime it goes up, it's a positive. Anytime it goes down is a negative. Anytime it goes straight across, it's a 0. And anytime it goes up and down like a vertical line test, that is an undefined slope. So this one has a slope of 2. But let's say I didn't know it has a slope. Not a slope of 2. I keep on getting it wrong. The slope is 0. So this one has a slope of 0. I already know that. So then I want to figure out why it has a slope of 0. So the way I would do this with Desmos is I would get this point. This is my y-intercept. It is 0, 2. And then I will get any other point. It doesn't matter if it's this one in green. It doesn't matter if it's this one. It doesn't matter if it's this one, as long as it's on the line. So I did this one. It's going to be 0. No, it's going to be 4, 0. So I'm going to put those two, 0, 2 and 4, 0 into Desmos. And I'm going to let Desmos do the work for us. So I'm going to get rid of that one. So I have 0, 2. And then I'm going to have 4, 0. And remember, a straight line has a 0 slope. Don't forget that. A straight line has a 0 slope. I'm going to add regression, and right there, there's something wrong going on with this. So remember, a straight line has a 0 slope. Let's check it to make sure we got it right. 4, 0. I inputted it correctly. That is correct. And then I have 0, 2. That is correct. We have a 0, 2 and 4, 0. But my line is not correct because remember, 0, 2 is this one. So right here, if I look at this one, it's not 4, 0. That is incorrect. And just by doing that simple mistake, this point right here is actually 0. The x is right here. The x is no, that's correct. This one is not correct because it's not 4, 0. My x value never crosses the x value. My x value is actually 0, it's actually, oh wow. Okay, so this one is actually doesn't have a point here. So then what we're going to have to do is we're going to have to scratch this and we're going to have to look at the equation and regroup on this one. So I'm going to look at this one. I'm going to say, well, it's -3, 2. This is -3, 2. And then this one is 4, 0, which is, no, 4, 2, sorry. My bad. Okay, I figured out where my mistake was. So let me go back. I was trying to put 0 there. No wonder it was wrong. So let me go back. I figured it out. So this is 4, 2. So that was a mistake. So I was supposed to put 4, 2. Now I'm going to add regression. And there it is. Y equals 0x plus 2. So if I look at that, I'm going to rewrite the equation. Y equals to 0x plus 2. And my slope is 0, the one we proved. So this would be D. Now, look at the equation. 0 times x is 0. So this is the same thing as writing y equals to 2. And my answer choice for the equation is y equals to 2 is letter C. And that is my equation. That was an interesting one. I was wondering why I was always getting it right. And probably through the screen you were saying, Mr. Ocaña, it's 4 comma 0. No, it's 4 comma 2. And I think that was the problem right there. And if I would have done this one, then it would have given me the correct answer. So a simple one that I turned very hard. Okay, which is a relation respect with y is a function. So we're trying to figure out whether it's a function or not. The way you can figure out whether it's a function or not, let's draw a line. We know that this right here is a vertical line. It goes up and down. If it passes through one point on the vertical line test, then it is a function. If it passes through 2 points, it is not a function. Or if it has 2 x's, it's not a function. So I do a vertical line, it passes through 1 point, so that line is a function. If I do a U shape, like this, is that a function? Well, I do the vertical line test, it passes through 1 point, I do a vertical line test, it passes through 1 point, I do a vertical line test, it passes through 1 point. So that U shape is a function. Now let me do a U shape going sideways, like this. I do a vertical line test, and it passes here, and it passes here. So that is not a function. Why? Because it passes through 2 points. If I do this one, V shape like this, sideways, is that a function or not? So I'm going to do a vertical line test. It passes through 2 points. That is not a function. And let's say I do something like this. I do a vertical line test. That is a function because it only passes through 1 point anywhere I do a vertical line test. So now we're going to look at the question at hand. Is y equals to negative 3/4 x? So if I would input this into Desmos, it does give me a line, so it is a function. Now the next one has 2 x's, 2 y's, 2 x's here, 2 x's here, 2 x's here. Remember, it can only have one x for it to be a function, so this would be not a function. And of course, the last one would be a function. Why? Because I do a vertical line test anywhere on this graph, and it only passes through 1 point. So this one would be a function. So that's how you do it quickly. You have 2 x's, not a function. You have a vertical line test. And of course, this first one is a line. And of course, I do a vertical line test, and it only passes through 1 point. The next one, and I'm going to go ahead and clear my screen so it won't be that messy. The next one is looking at that one. I'm going to have to determine whether it's association, causation, both, or neither. So you can pause the video, try them out, see which one's association, causation, both, or neither, and I can give you the answer. So number one, when the speed of the car decreases, the arrival time of the destination is later. That's a cause and effect, so that is correct. The car speed is associated with the arrival time. That is also correct. So the correct answer choice is B. It is both association and causation. If I look at the second one, when the temperature increases, the sale of snow cones increases. So are they associated to each other? Yes. Is it a cause and effect? No, because snow cones can increase in Harlingen but decrease in McAllen. So that is not correct. So it can't be both. It cannot be neither. So it's an example of only association. And last one, when the oven temperature increases, the cooking time for a casserole decreases. That's associated with each other. That's also a cause and effect, because wherever you have the cause and effect, it's going to happen, whether it's in Florida and South Padre Island, it's going to be consistent across the board. So this is an example of both association and causation, because the temperature is always going to be consistent with the cooking time of the casserole. So it's an example of an association and a causation. I'm going to go on to the last one that we're going to do for today. Which expression is equivalent to 7 square roots of 5? So that's a very simple input into Desmos. And I'm sorry I couldn't do all of them, but we are out of time. So square root of 45. That gives you 46.95. And remember, equal means that they're equal. So we're going to test out every single one of them. 12 square roots of 3. Not 46. I'm going to test out the next one. 35 square roots of 3. Not 46. I'm going to test out the next one. 10 square roots of 5. Not equal. And the last one has to be the answer. 21 square roots of 5. And it is equal to 46.95. And the answer choice to this one is letter D. So once again, looking at every single question, what I would recommend on the video is to look at the problem, try the problem on your own, pause the video, work it out, and then check to see if you got the right answer. If you got the right answer, then you know you're doing it correctly. If you didn't get the right answer, find out why you didn't get the right answer and go back and redo it until you get the right answer. So I hope this has helped you a little bit. My next video will be on a little bit more STAAR prep, and this time I will divide it into 3 pieces because we do have a STAAR prep right before the STAAR test on December 9th. So hopefully everyone has an amazing day. Thank you for spending our time with us. And again, I commend each and every one of you for doing an amazing job, outstanding work in our math, Algebra 1, and of course, class. Thank you for your time.